Hi, it's Valentine from Simplistic. And in this problem, we have a base, a weak base solution, 0.33 molar, and we have to find the OH minus ion concentration and the pH. So let's go ahead and first represent this base, methylamine, with something simpler so we can draw the equilibrium. Let's call it MEA. Okay, so we write MEA aqueous plus H2O, which gives us MEA. It picks off an H plus from the water, and then what's left behind is OH minus. So the OH minus ion concentration is coming from the reaction of MEA with water. Okay, so initially we have 0.33 molar. We have we have nothing on the right. The change is going to be minus X on the left and then positive X for both the entities on the right. And at equilibrium, we're going to have 0.33 minus X on the left and then X and X on the right. So now the equilibrium expression for this, because we're dealing with a base, it's going to be Kb, which is the base dissociation constant, is equal to MEAH plus times the concentration of OH minus divided by the concentration of MEA. Okay, so we just plug the values in. So X times X over 0.33 minus X. And Kb, we pull that from a table. That is actually equal to 4.4 times 10 to the negative 4. All right, so we're just going to take this quantity and then this and solve. So we get 4.4 times 10 to the negative 4 is equal to x squared over 0.33 minus x. So to make our life simple, we're just going to ignore the x at the bottom. We're going to assume that it's too small. So if we ignore that, we get x squared is equal to 0.0001452. And if we take the square root of both sides, we get x is equal to 0.012. So this is the concentration of OH minus. So that is one part of the problem figured out. We have the concentration. Now, before we move ahead, let's go ahead and test our assumption that x is indeed small. So to do that, we take the value of x that we got, which is this, and divide it by what we subtracted it from. And if the answer we get is less than 0.05, then indeed our assumption would be correct. So we take 0.012 divided by 0.33. It turns out we get 0.036, which is indeed less than 0.5. Therefore, our assumption is correct. We can move forward with this. So now the next step is to find the pH. Now it turns out we cannot find the pH directly out here because we only have the OH minus ion concentration. So we have to use this relationship. pH plus POH is equal to 14. So we can find the POH because we know what the OH minus ion concentration is. So let's go ahead and find that. So POH is equal to the negative log of the OH minus ion concentration, which is equal to negative log of 0.012, which gives us a value of 1.92. And then if we plug that into this relationship, we get pH plus POH is 1.92 is equal to 14. Let's add two zeros out here. So pH solves out to be 12.08. And there you have it. That is the pH of the solution. And that is the OH minus ion concentration of this weak acid solution. I hope that made sense. Thank you for watching.